You know what? I wrote down the problem because I was working it out in my daughter's like, what's going on? Yeah.
Okay. I was gonna walk by.
You can walk by, it's fine. The one that's 32 and 1/2 minus 16 and 1/2 square. And this is so basic, but I don't remember how to make those whole numbers. And it ends up being like the example they gave was like 100 minus 80, I think equals 20. It's so basic, I know, but I think it was like you just times the denominator by the 32 and then times that by 1.
Yeah, let me pull up the question you're looking at. That might be a little bit easier to.
Yeah, 32 times 2 equals 64. So I think it's 64 minus equals times 2 equals. Maybe I don't know if that's right or not. So I don't know if that answers 64.
Okay, so
I think I just figured it out.
yours. So this was in section 1.2.
Yeah.
And it looks like it's question 11, the 32 times 1/2 and the 16 1/2 squared.
Yeah, I think I just figured it out talking to you. I think the answer is 64. But
I can double check.
I didn't put it. I don't know how to do it with.
But it's a good question to make sure you understand the process behind it. The answer is 12.
Okay, so
to that. So let's take a look. So essentially what you want to do is follow order of operations because you have some multiplication and some subtraction and an exponent. So you have different operations going on.
Right. Oh, I just saw that one. Okay, yes.
So you do that exponent first. So the half gets squared. Do you know how to do the half squared?
Just wouldn't it just be 1/2 times 1/2?
Yep.
Okay. So it would just be 1, right?
Well, how do you multiply fractions?
So would it, okay, so it'd be 2/4, so it'd be 1/2. Would that, okay, I don't know. I'm like feeling.
No, that's what we're trying to figure out is, where things are going wrong so we can help. Let me bring up a screen and I can show you how to go about that. There was a way to do that. So
so it wouldn't be 2/2. I thought the denominator stayed the same, but it doesn't.
No, the denominator stays the same when you're adding fractions. You need a common denominator and it stays the same, but for multiplying, you multiply across the top and across the bottom. So you're going to do 1 times 1 for the numerator and 2 times 2 for the denominator.
Okay, so it ends up being 1/2, right? Because we need to.
So 1 times 1 on the top.
Oh, 1. Oh.
And then 2 times 2 on the bottom.
Okay, so 1/4. Okay.
And then if you think about like if you're cooking and you have a half a cup of something and you need half of that, how much of a cup would that be?
You mean half of a
half of a half cup?
Half of a half. I don't even know.
So if you took a half cup of flour and you divided it in half, you took half of that. How much flour would you?
Like is it a quarter? I don't know.
Exactly.
Yeah. Okay.
So now we have 32 times 1/2 minus 16 times 1/4.
Right.
So you've done your exponents, and now we're going to do our multiplication.
Okay.
So you're going to do the 32 times
1/2. So you do okay, how do you 32 times do you you put the 1 underneath the 32 and then it ends up being 32/2?
Yep, that's one way to do it. Or you can say 32 times the 1, so the 2 numerators, and then divide by 2, or you can cross multiply. There's different methods depending on what you've done before.
I know. I think I first learned this in the 80s. So for me, I know it's like my daughters are always like, you're doing it wrong. 16/4. Okay. So then, it'd be 16 and So then it'd be 16 minus 4, so the answer would be 12.
Yep.
Okay. Yeah, I get it now. Okay. That makes sense.
Yeah, it's just an order of operations. You just have to be kind of careful, and then there's exponents in it, so there's an extra level of concepts being tested. So, there's a couple things going on there, working with fractions, working with exponents, and working with order of operations.
Right. Okay.
It's not an easy problem, but
it is.
it will get there. But I mean, at first, like, it's not like the easiest. Like, you do have a couple things to pay attention to. So any area where you're, needing work on can trip you up. So there's lots of areas for mistakes to happen. Yes, it is a generally relatively easy problem overall for Math 80.
Yeah.
But there's different places where you can make mistakes.
Right. I think that is all. I started like watching the videos on like the subsets, and not the subsets. It was that's what it was. That was kind of new to me too, but it made sense. How to see if the number was rational or not. I watched a video. It kind of made sense. I need to take notes on it so that I remember. But I can't. I'm just trying to get through it. I'm just plugging away.
Mm-hmm. So for the lesson part, like 1.1, we naturally start. If we want to kind of talk about 1.1 and the basic concepts of it, the real number system, right now for the first couple chapters, we're only dealing with real numbers. So we've got the natural, where you naturally start counting as a little kid, is 1, 2, 3. And then we realize, well, there's such a thing as nothing, like no more, there's just nothing. And so our idea of numbers expands to include 0. Whole numbers would be that. And the way I remember that is the word whole has a 0, like an O, looks like a 0 in it.
Yeah, okay.
So whole is the next one, just adds in 0. And then integers, okay, the next thing we start learning is positives and negatives. And so those are, and we don't deal with decimals or fractions yet. So the integers are just like -3, -2, -1, 0, 1, 2, 3, etc. And the integers are the ones that we normally put down on a number line. When we make a number line, we normally put down the integers, and then sometimes we add in smaller tick marks for, tenths or thirds.
And that was in one of the, I don't know if it was in, it was in one of the questions.
Yeah, where they broke a number line up into little other marks, but we generally, when we make a number line, just, go from negative to positive integers. And then we start learning about fractions and decimals. And so that's the rationals. And the word rational has the word ratio in it. So a ratio is a fraction. And so it's anything that looks like a fraction or could be written as a fraction. So for example, 3, it could be written as 3/1. So it is rational. It also is an integer. It's also whole, and it's also natural. So some things can go into many groups. The further out you are with these, natural, then whole, then integers, then rational, it starts incorporating more and more stuff. And then for rationals, you can also have decimals that terminate. So like 3.2, it terminates because 3.2 is really 3 2/10. So it can be written as a fraction. Same with repeating, which you often see the bar over it. So like 7.3 repeated with a bar over it, 0.333333 is a third. If you put it in the calculator, it'll come out a third. Or if you put in 2/3, you'll see 0.66666 repeating. Or if you put in 1/4, you'll see 1 divided by 4, you'll get 0.25. It terminates. So things that repeat or terminate can be written as fractions. So they become rationals. And then things that cannot are the ones that are irrational. They're like wonky, right? They're not the same. Irrational are like the square roots of non-perfect numbers. So like the square root of 2, square root of 3. But like the square root of 9 is really 3, so it's not irrational. Square root of 9 would actually be a rational number. And then there's pi is another typical irrational. So basically when you see the square roots and you see the pies, those are the irrational.
Okay.
So there's a bit of a discussion in the course about the numbers. I try to go into a little more detail on that on the Canvas site.
I didn't see it. Yeah. I was actually having a hard time getting onto our class. I had to go in through an email link. I don't know. It was weird. I was fine earlier today at work, but on my MacBook, it wouldn't. I don't know.
Into Canvas?
Mm-hmm.
I know I have issues going into Canvas. I have to go from the original. I can't like have a saved, like the saved login page never works for me.
Okay.
I have to like go back to either Distance Ed or from the main Mendocino College website. There's now they put a link at the top of it.
Okay. Yeah, I was able to get in through my email, but
that's strange. Yeah, I know that I can't, like, if I've signed out, it won't let me sign back in from that same place. I have to like start over.
Gotcha.
So hopefully if you just do that, if you just always start at Mendocino College's main page at the very top, hit Canvas, you should be fine.
Yeah.
Another topic that is often kind of new to students would be that set notation stuff that you were talking about. I think you mentioned the
yes, that is what yeah, that was new to me.
And we're not going to do a ton with that in this course. It's really to introduce you to it for future courses, because as you go on in higher math, they start doing a lot more with that notation, because it's shorthand for things that are just a little more complicated, and it's just a quicker way to say things than writing it all out. So there's different symbols for things. So the set just means there's a bunch of objects that have some sort of, they're grouped for some reason. So we might have like the set of even numbers, because they're all even, or we might just have a set of numbers that we're looking at. And so the individual things in that set are called the elements. And there's a symbol that kind of reminds me of an E, kind of a rounded out E.
Oh yeah, that was in chapter R11 too.
Yeah. And then there's the subset. It looks kind of like it's being eaten, like it's being swallowed up by the next thing. So like A, there's kind of like a sideways U, and then a B would mean A is a subset of B, like it's contained in. And so it kind of reminds me of a C or a sideways U. But if you think of it as a C on its side, I think of it then as contains. So like if it's A subset B, it means A is contained in B. And so I like to think of it as a C. It's not really, it's really read subset, but that's how I know which direction I'm going.
Okay.
I think they actually mentioned the word contain too in their definition. Would you like any practice with the subset stuff? And
I should.
Okay, well, I'm trying to, yesterday when I was playing around with this, I found a way to share something with you. Let me see if I can do that again. Share. Oh, there we go. Let me open up the
this is where I need to like write this down to remember, because it's like it gives you like a set, a list of numbers, and it asks you like which ones are whole numbers, irrational numbers, integers, real numbers. It's just, I don't know, so I need to like write it down.
Yeah, so let's practice both of those things that we've talked about.
So whole numbers cannot be negative, apparently.
Right. Whole is from 0 on. Like the word whole has that 0 in there, and it's from 0 on.
We'll tell them.
And then let's practice a few. Let me bring this back up and then share it. That's why does it say syllabus? It's not what it says it is. Okay, do you see my screen that says?
Yeah.
Okay. So there's some practice problems over here. This is my notes from when I teach the on ground class, but it's a little bit different for the online class. We have you guys watch more videos, have more discussions, read more in the textbook. But that's what I thought today, you know, it might be helpful to have more of the lecture. So I can go through bits and pieces of my notes where we want more practice.
I should take a picture of that. That's okay, I don't have my phone. Yeah, because that is helpful. See, I like just visually saying that like helps me understand it.
Yeah, and I'm happy to share any of these. It's not like ADA accessible. That's why it's not what I post to Canvas right now. And it's, but I'm happy to work through these examples.
I understand it just by looking at the picture.
Okay.
So, I need to like take a picture of that just so I can reference back because like, or put it in my notes because,
do you want this part filled in before you take the picture?
No, it's okay because it's all right here. Like, I just need to grab my phone. Do you care?
Oh, that's fine. Go for it.
Okay, it's just in my room. Okay. Yeah, if I just take, yeah, that way I can just write it down in my notes. That really explains it. Okay, cool. Yeah, that's helpful.
There is this visual. I also find sometimes people don't like that visual because they don't know what the inside circles all mean, but that's the whole idea of a subset. So this other one that's showing it just with like the list, some people like that more. So that's another way of organizing it.
I like the other one, but
yeah, this one's kind of has examples right in it.
Yeah, I know I like that one.
And then I would make a special note in my notes that the rationals, what that means is that, let me see if I can, what is this doing? It means the decimals would repeat or terminate.
Oh yeah, I saw that in repeat or terminate. In one of our, I think the example was like 0.333 ... or something.
Yep.
So those are rationals. Okay.
Yep, and that's what actually this box would have been for if we were in class, repeating or terminating decimals, just to reiterate that. But all right, so then let's get out of this text thing. No, so there we go. Clear. Okay, so the subset stuff is here, and there's some practice right here. So question 1 is referring to and this was a typo before, so it just should be, is A contained in B, is how you would read that. Is A a subset of B? So is everything in A contained in B? So is 1, 3, and 4 in the set B?
And so the answer is no, right? Because 4 and 5 are different.
Right, but are these in this?
Yes.
So that'd be a yes. So A is in B.
Okay, so it's that contained. I guess I just think of it as a C. Okay. Contained. But then and it goes the other way too sometimes, right?
The symbol?
Yeah, no. Okay.
This symbol is always facing like a C to when it's meaning subset.
Okay.
So you might change the direction. Like it might ask you, is B contained in A? Is B a subset of A? So is B all in A?
Okay, so no.
Or not?
Well, yes. No, okay, no. All of B is not an A.
Right, because 2 and 5 are missing, right?
Right.
Okay, so is 5, and now we have a new symbol. This is the E looking one, which is the one that's red element. So is 5 an element in A?
Is 5 an L? No.
And is 2 an element in B?
Yes.
There we go.
Okay, that's easy.
And then when things don't have any answers, we sometimes use this symbol like that. We call it an empty or null set. There's another symbol we sometimes use as well that looks like this. It's basically a set that's empty. So, so when we're doing the questions with that, we can have things like A is this, so find C if C is X. So it's the elements where X is an element of A. So we're looking for things that are elements here, so it's any of these things. And it needs to also meet the criteria that X is less than 3. So things that are in A that are less than 3 is what this is. And this vertical line here means such that is how you read it. So X's, the values, where the values are in here and are less than 3. So what things here are less than 3?
Okay, so just the 1 and 2.
Exactly.
Okay. That makes sense because I would have never known that based on the X's would have confused me. I would have thought that I was like looking for a number.
Yeah, they sometimes, X is kind of like the generic variable.
Mm-hmm.
So then for part B, how would you read that?
So a number that's greater than or equal to 9.
And that is element of A.
Right. And so like nothing.
Exactly.
Yeah.
So you can use either the symbol that I have here or that other one that looked like a 0 with a slash through it.
Okay. Oh my gosh, this is so helpful. Okay. Yeah. That makes sense. Okay.
All right. So if you want, do you want to take a picture of anything or?
I did. Okay. Yeah.
Well, clear then.
I just want to go back and like write it in notes.
Yeah, it's a good idea. Let's see. So then there's 1.2 is on properties. And essentially there's 2 that students often get kind of mixed up, and that's commutative and associative properties. And so the key thing for the commutative is that they're commuting. It means just like you go from work to home and then you go from home to work. You're switching the order. So order switches.
Okay.
Then the associative is the order isn't switching. So you can see it says A, B, C, and then A, B, C. So the order hasn't switched there.
Yeah.
But what's changed is the grouping, the parentheses. So what is grouped? Oops. Switches or changes. So the letters don't, but what's been parenthesized does.
Right. This part I felt like confident with.
Good. I'll give you a tricky question then.
Oh, okay.
Number 5.
Okay.
What do you think? What property is being illustrated with number 5 down here?
Associative.
Why do you say that?
Because everything's the same, but just the grouping changed. Well, actually, the X is, so it's commutative.
Good, yeah. So it kind of fools you because you see parentheses, and our natural inclination is to say associative when we see parentheses, I think.
Right.
But like you said, the order actually did change. Right. And what's grouped didn't change. The y plus 3 is still y plus 3 being grouped. So, all right. Let's continue on then. And then just some questions that can be a little bit trickier might be like, number one is pretty straightforward, distributive property. Number two can get a little bit trickier just because of having a fraction involved. Some people aren't comfortable with fractions, and so that can be a little bit harder.
Yeah, I'm not a fraction person. So to do that one, minus 2 over x. I'm always thinking, so would it be 3x minus 2x?
Not quite, but close. So 3x from the first part.
Yeah. And then over 1.
And minus. And now what you're going to do is you're going to do, so you did the 3 times x. Now you're going to do the x times this. So let's just write it out here like x and then 2 over x. I need to get a better mouse situation here. There we go. So you basically have 2x divided by x. So have you done much with cross canceling?
Yes.
Okay, so this is the fraction where, you know, it might be hard to write. You could do x over 1 and then do 2 over x, but it might be easy enough just to go, oh, those cross cancel.
Right.
X divided by x is 1.
So
and
it's just 3x minus 2.
Exactly.
Yeah. Well, sometimes I get confused with when you can cross cancel, when you can multiply, when you have to like add. So I'm just trying to remember all of that. So 3x minus 2. Okay, that makes sense.
Yeah, so I don't know who your teacher is, but oh, actually I do. You have me for the online class, and then I'm getting confused because I also am doing 31's office hours. So
I did like a 0 credit class that I think you go to the college. I'm not actually sure. I enrolled in it just because I was like, oh, this would be nice if I need extra help. I can, you know, go in, but I don't know how to go about it. So
yeah, I
think it's Chris Tyner.
I don't remember seeing your name show up though on 30 or on 5. Maybe it's because it was 531.
I don't know.
Because we had an issue with connecting them, but I thought it got resolved on Thursday night. So I'll double check.
So the class is 531, and that's a 0 credit class, right?
It is. You still have to do all the work to get the credit. It's just that it's like credit, no credit. It's not like a letter grade.
Mm-hmm.
And some people prefer it because of financial aid. You don't want to have too many units.
I don't have financial aid.
Then you might consider doing 31 instead of 531.
31 instead. Is that like what it was? It's not
the exact same course. Sorry, my baby girl's just over 2 weeks old, so getting used to the whole crying thing.
I know, it's a new baby cry.
Yeah. So 31, if you did it for 3 credits, you would either get like, you know, an A, B, C, D, or F grade, and then 531, you would just get credit or no credit. But it's the exact same course. It doesn't look any different to any of you. It's combined in one Canvas shell.
Mm-hmm.
So it's something to consider. You'd have to make a decision in the next week or so.
So I would have to drop this class and do that one?
Yeah. If you wanted, you can stay in 531. There's no problem with that. It's just if it depends what you want.
But it's the same exact class, right?
Yeah. It's just some people don't want to have the credits because of financial aid, and some people just don't want the stress of, oh, what if I get an A or a B? They just want to have it credit, no credit.
Well, don't you need it for your it's like this is the only class I have left for my like general ed. So
the math 80.
Yeah, so the 31 wouldn't qualify.
31 no, so 31 and 531 are support classes for Math 80.
Okay. You know what, that I wonder if I didn't realize that there was extra work in those classes.
Yeah, I don't think I saw your name on the roster either. So I will double check and message you.
Because I'm enrolled in 2 classes, but one, it was like a no credit. I know it was no credit, but I didn't know that you were going to have to do work in it. I thought the way that the counselor, this lady, described.
Maybe you signed up for 30. That's another support class that doesn't have nearly as much work.
Well, she's like, you can show up if you want to show up, and you don't have to show up. It's just there if you need extra help. Because I probably wouldn't have done it because, to be honest, like this is all I probably can handle. Like,
yeah. Okay. So I'm thinking now that you're saying that you can show up or not show up, that maybe it was. Let me double check the number. I think it's 540. 540. It's the math lab.
Oh, yeah.
And that's on campus.
And I don't have to go to it though.
Yeah, if you did the 0 units, you don't need to go to it. It's like a drop in whenever you want in the library. I'm sorry, in the learning center.
Okay, that's what it is. Yeah, because the 531 and the 31, there's support classes for the Math 80, but there's homework in them too, right?
Yes.
I don't know. Do you suggest it?
So it's quite a bit of work. So if you, you met the requirements to sign up for Math 80 without it, apparently. So, as long as you make use of the lab, I think, and, coming and asking me questions, I think you'll be fine. It's really, if you haven't had algebra, and you've already started algebra, this Math 80 in the past.
Yeah, so. And I was doing fine with it. I think I was actually doing just fine. I just, in all honesty, long story short, I just couldn't continue because, my house burned down. So I was like, about. So that's the only reason why I was just like, oh, I just can't do this on top of everything else right now. But other than that, I was doing fine in the class and keeping up. It was a lot easier then than now, and I don't know. I think I was just maybe more mentally prepared then for it than I am now because I'm, whatever. So I just have to get into the mindset again and just get my brain in.
Were you doing that on ground or online?
It was online.
Okay. We've also changed textbooks.
Yeah, that is what I think I'm mostly struggling with because before I was just zipping, I didn't even have to even barely the first 3 weeks to a month. I was just but I don't know why. I was just this is so different. I was struggling. I was struggling.
I think it'll be bits and pieces that are new or different or didn't necessarily show up at the beginning of your course that are now showing up at the beginning of this course. So I think, there'll be pockets where it's easier and harder. And then at the very end of the course, it's very new stuff that often is harder then because you haven't had exposure to it in the past.
Right.
So let's move along a little bit further on this. So number 3, the reason I put this in here is because there is distributive, but it's important to recognize that the negative, it says 3 minus 2, but really it's 3 plus a negative 2. So this negative is part of the 2, and so it gets distributed as well. And a lot of times people forget to distribute the negative. So always take the sign with your numbers.
Yeah, I think it was in the first homework assignment. That was one of the questions. And the second time, I got it wrong the first time, but the second time I realized that it was a negative number. So that one would be negative 8x. And then it would be negative 6. So it'd be 3. And then would the 3 become a plus, or would that be changed to a multiplication?
So it doesn't become multiplication. The original problem was 3 minus. So, you're not going to change subtraction, or you can think of that as 3 plus a negative 2 at the beginning. You're not going to change it to multiplication. So it's kind of like 3 and then minus 6 are like terms to be combined still.
Oh, Because you get rid of the parentheses. Okay.
Yep. We need
So,
the distributive property. It removes the parentheses.
okay, so would the answer be negative 8x minus 3?
Negative 8x minus 3. Yep.
Got it.
And then number 4 is, I want to show a fraction, one that might be, important to learn how to deal with, and the negative. And also that's kind of order of operations problem that number 3 is. We did that multiplication before we combined or added our like terms.
Right.
And then number 4 is one that involves a decimal. And one of the things that we're going to learn later on this course is how to get rid of problems that involve fractions or decimals. And we're going to learn this method called the LCD, or lowest common denominator method.
Yeah.
And so for number 2, the lowest common denominator is an invisible 1 here and an x. And so an x here got rid of all the fractions. Yes. And when we look at question 4, we have decimals. And when we distribute that 100, because this is in the hundredths place and this is in the tenths, we will get rid of all the decimals.
Right. So it becomes what, 60 m plus 217.
Exactly. So now you've cleared your decimals. Now those are equivalent expressions. Yeah. You have to be careful, like if you multiply one side of an equation by 100, you'd have to multiply it by another. Or if I just took this expression right here, that's not the same as this one down here. Multiplying by 100 changes the value. But if you're trying to get rid of decimals while solving an equation, you're going to apply the same idea of the lowest common denominator, or a power of 10.
Okay.
All right. So let's see. Let me clear that. How do you feel about working with positive and negative numbers, like adding and subtracting positives and negatives?
I'm okay with it. Like, I was like, oh yeah, okay. Like, I know, like a negative and a positive is a negative. 2 negatives is a positive. Like, I'm okay with it, I guess. Like,
and so we'll skip this, and this is all in your textbook too. You can see that most of these things are just screenshots of the textbook anyways. Order of operations, I don't know if you've heard of PEMDAS in the past. That's how I learned it. Please excuse my dear Aunt Sally, is actually how I learned PEMDAS. But there's kind of a move to change, instead of calling it PEMDAS, to do what's called GEMS. And the reason there's kind of a move for that is that students were always doing, let me write PEMDAS here as well so we can see it. PEMDAS. Students were always doing the multiplication before the division, which isn't correct. This actually means multiplication or division, whichever comes first, left to right, and then addition or subtraction. And so by doing this, it was multiplication or division, whichever comes first, left to right, subtraction, whichever comes first, left to right, or addition. And so this is how they kind of did it. Here is that beginning with the parentheses or brackets, that's the grouping symbols. Right. And then the exponents, exponent, and then multiplication or division, whichever comes first. And then the next one would be subtraction or addition, whichever comes first, left, right. And that way you don't get stuck always doing multiplication before your division, when you might do division before multiplication sometimes. So there's a couple practice problems down here. One, there we go. And so you can see that on here, you're going to do this division before you would do the multiplication, because again, it's division multiplication comes first.
plus 1. Oh, I probably don't need this.
No, I'm not done, but are you?
So in this case, would we do, would it just be 20? Well, we would have to do lesser, right? So it'd be 8 minus 20 plus 1. So would that be, would it be 8? Would that become a negative and a positive? Or, what the heck happened here? So the answer would not be 13, right? Because you'd have to do the 8 minus 20.
Yeah, so that is negative 12 then.
Right, so it'd be negative 12 plus 1. Yeah, I guess I do need a refresher on this because I forget.
Yeah, so basically the way I think of it is when you're adding things together, you know, what do you have more of? You have more negatives, so your answer is going to be negative.
Right, yeah, I know it's going to be negative, but then if it's plus 1, I just don't remember if it is, if we subtract or, so does it end up being negative 13?
Ends up being negative 11. So like think about a number line. If we're at negative 12 and then we add 1, we're going to be at negative 11. That's one way to do it. The other way is, you know, we have more negatives, so your answer is negative. But they're not all negatives. So you're not going to have 13 negatives because they're not both negatives.
Okay, right, because we're adding them, not multiplying. Okay, so, okay, that makes sense. I got it.
And then another thing that often gets tested is the difference between 0 divided by a number and a number divided by 0. And because multiplication and division are inverse operations, like if I multiply by 2 and then I divide by 2, I'm back to what I originally had. Okay. So we can have like 0 divided by 5 is going to be 0. You can have nothing. If you divide by 5 people, they all have nothing. And you can also check your work by saying 5 times 0 is 0, versus the one underneath where you're dividing by 0, which I'm sure you've heard you can never divide by 0, but you know, 0 times nothing will get you 5. And so that's why it's called undefined. That's the word they use to describe dividing by 0 is undefined. It shows up when you also do slope. You have an undefined slope when you have a rise, like a rise of 5 and then a run of nothing. So like that is an undefined line. The vertical line is undefined because rise 5, run none. And then a slope of 0 means you rise nothing and you run 5. And so it's no steepness, no slope. Or I should say a slope of 0. So let me get rid of that stuff over there. Exponent rules. You'll notice that this came from the textbook, but I added in number 9 here. I would recommend writing that down as an extra rule. That's a little bit of a shortcut. It's a time saver.
Okay.
So it combines the rules 4 and 5 together. Having a negative exponent essentially flips it. It's a reciprocal. And then it also involves number 5, which is, you know, when you have a fraction to an exponent, that it applies to both.
Okay.
Another thing that often gets tested on is that a student understands the difference between negative 5 being squared and the opposite of 5 squared. And you can even see that I read that differently. So this is really saying this negative 5 is being multiplied by itself. So you'll have a negative times a negative, you'll end up with positive 25. But this is saying that it's basically saying the opposite of just the 5 is being squared. So the negative isn't part of any parentheses, it's not part of what's being squared. Only the 5 is being squared. And so the answer there ends up being negative 25. So I would highly recommend writing down this example 9.
So, okay. Oh, because, okay, I got it. Because the negatives left over.
Exactly.
That's how that happened. Okay, so negative, okay, MB. I'm writing this up super fast. Because two negatives. Okay, that makes sense. Okay. Okay.
And I did include into Canvas some practice problems on a worksheet. And here are more. These are problems that are very typical for testing exponents. There's some that are very straightforward, and then there's some that are a little more involved, particularly negative exponents. So if you had a problem like number 6, let me see if I can't zoom into 6 a bit more and get this out of the way. Here we go. That way I can maybe write on it. Okay, so for number 6, I see that there's a numeric fraction portion. So I'm going to take care of simplifying that fraction. So what is 3/15 reduced to?
1/5.
Okay, so I divided both top and bottom by 3, and you get 1/5. And the 1 isn't really necessary because you'll have other stuff. But if everything else goes away, you need to have a 1 placeholder. You can't just change a denominator to all of a sudden being a numerator.
Okay.
So let's look at these negative exponents. To deal with a negative exponent, you take the reciprocal. So you flip it from bottom to top or top to bottom. So this one is going to come up here and become positive 2. This one is going to come down here and become positive 7. And this one's going to go up here and become positive 3. So just take things step by step. So I'm going to have m to the 5th. Let me see if I can use my finger a little bit better. W. We're going to also have x to the 2nd, because by bringing it up, we made it positive, and m to the 3rd. Again, by bringing it up, we made it positive. And then on the denominator side, we still have w to the 5th, and we're going to bring down the x to the 7th. So now at least it's all positives. And so now I look at, okay, I have the 1/5, and I'm going to look at maybe one letter at a time, so my m's.
How did we get x2?
Because this had a -2, so we brought it up. And then this had a negative, and we brought it up. That makes them positive. So when you change their position, it changes their sign.
Okay. But then, and we didn't bring W up because there was already a W up there. And then we brought X negative.
Hold on 1 second.
Yeah.
Okay. The door and the baby are done making noise.
Yeah, it's okay.
Okay. So you were saying,
yeah, this has me super duper confused. So we want to make everything positive.
Yeah.
So in order to make it positive, we just moved the -7 down, and then the -2 and -3 up.
Yeah.
Okay. I got it.
So now we're just dealing with positives. And the reason I like to just make them positive from the very beginning is I don't like to apply the rule that says, there's a rule that says, you take your top one and you subtract the bottom, but then you have -7 minus a -2, and it just gets really complicated because you end up having lots of double negatives, and then you still might have a negative on the top that then you have to deal with later and put it on the bottom, and so it just often makes it more work.
Okay.
And it's a lot easier for us to think about 7 of something. It's hard to think about -7 x's. Like, how would I draw that? I can't draw x to the -7th. I can draw x to the 7th. It would mean x being multiplied out 7 times. And I could show that literally. And so now let's look at like m's, for example. I have 5 m's being multiplied. So you can, think about 1, 2, 3, 4, 5 m's. And then I have 3 more. So how many m's have been multiplied in total?
Right. So there's 8 m's. But
So that rule says you can just add, I have got to get my other screen that allows me to write better, m to the 8th. And so that rule just says you can add exponents when you're multiplying with the same base.
Okay, so now we're just combining.
Mm-hmm.
Okay, so then we would just do the W and then the X2 because, we can't, we're combining those?
We can only combine things with the same base. So now we're going to deal with the W. So I have a W on top and 5 W's on the bottom.
Okay.
So where do I have more W's?
On the bottom.
How many more?
Well, how many more? 4.
4 more. And so whenever you're stuck on these exponent problems, you can always draw them out as long as you've made them positive.
Okay.
You don't have to memorize any of those rules. You have to just understand what this is meaning. So when we look at the x's now, it's x times x, and then there's 7 x's down here, 3, 4, 5, 6, 7. So those cross cancel. Where do I have more? The bottom. How many more?
5.
5. And you know, if the numbers get bigger, you just ask yourself, where are there more? Well, the bottom. How many more? Okay, well, 2 here, 7 here, so there's a difference of 5.
Okay. Okay, that makes sense. Okay, and so that's it. That's the answer?
Mm-hmm.
Yeah. Okay, that is actually simplifies it. Okay.
If we have like number 2, that 8 has a negative exponent, so it's like you're bringing it down. Right now it's like an invisible 1 right there. So if I bring this down, it's going to be a placeholder of 1, because essentially it's saying 1 times this, and then 8, make it positive because you brought it down. And then you can evaluate 8 squared. 8 times 8 is
64. Okay, so then that ends up becoming a fraction because I
Yeah.
was thinking that the answer was just 64.
Right. That would be, if it was 8 squared, would be 64. So that negative has to do something. And what it does is it creates a fraction.
I hate fractions. Okay, let me write this down. So then it becomes 1 equals 1 over 64. Okay.
Now this one, this exponent of -3 only belongs to the m. It's kind of like how we talked about earlier with that -5 squared. Remember that problem where it was -5 squared? The squared only belonged to the 5. You had to have parentheses for it to mean -5 times -5. So it's similar here. This exponent only belongs to the m and not to the 5. So sometimes putting little dots in between factors can help. So this would be 5 is still a numerator, and I'm going to change the m to the -3 to be m to the positive third as a denominator now. And a lot of people want to put the 5 on the bottom because they think, oh, there's this negative, and they see this as being a thing. So it's 5 times m to the -3. So every factor is dealt with individually.
Okay.
Just like here, I dealt with the 3/15 individually.
Okay. I wouldn't have gotten that one right.
Yeah, I put these practice problems to help people not make the traditional mistakes that are easy to make.
Yeah, no, that's super helpful.
All right.
The 5m3 times 2m5, that we would do that one just like problem number 3. Those are positive.
Yeah, so those are positive, so it's easier.
Move them, it's easier?
Yep, just 5 times 2.
Oh, okay. 10.
And then m to the third times m to the 5th.
Would it just be m8?
Yep.
Oh, well, that's easy. Okay, I was thinking I was going to have to make a fraction out of it. So it'd just be 10m to the 8th power.
Right, since there's no negatives involved, you don't have to create anything more challenging.
We like positives.
Yeah.
Okay. All right. Well, that's easy then. I would have made that one much more complicated.
All right. Did you want to take a picture of any of this scratch work here?
I wrote it all down
Okay.
while you were doing all of that.
Let's see. So like problem like this, I would make use of that extra property that I mentioned, where if it's a negative and a fraction, you can flip the fraction part and then make it the negative a positive. So essentially what you've done is you've taken care of the negative by doing the reciprocal. You've flipped it.
Okay, but
so
it's
top went to the
still,
bottom, bottom went to the top.
it's still a negative. The 5/2 becomes 2/5, but that's still a negative. So even though you flip that, it doesn't make it a positive. No.
So it's a negative exponent. This is a negative number. That's the difference. So it's the negative exponents that we do reciprocal.
Okay. I got you. This is, I guess, where I get confused. I'm making sure that I don't remember if these, okay, they don't have to have a common denominator. So is it just 2 times, it's -2, 5 times -2, 5. So it'd be 4. Oh my God, what's 5 times 5? I forgot. 25. Yeah, 25. So it would be positive 4/25.
Yes, if it was square, but it's cubed, so you need one more.
Oh.
So this part you had right. It was 4/25. You still need to do another negative 2/5.
Okay, I didn't realize it was. 125. 2. I second guess myself on all of this. So, but if there's 3, it's positive anyway. Or no, so it's 2 negative. It's 3 negative. So isn't it? 2 negatives become a positive, and then with the positive and negative, doesn't it become a negative again?
Yep.
Okay, so it's -8/125.
Exactly.
Okay.
And the last one here, 11, it just realize that, again, this is 3 times x to the 8th. And so the 3 is being raised to the 4th, the x to the 8th is being raised to the 4th, and the x to the 3rd is being raised to the 4th. And when you have a power to a power, the rule is, and essentially what it is x to the 8th, 4 of those, right? And so if you wrote this all out 8 times, this out 8 times, this out 8 times, and this out 8 times, you'd have 32 of them. Okay. So the rule is that you multiply, but you can also visually do it. I'm not going to write them all out 8 of them underneath here, but you can imagine, right?
Right. Yeah. So then so it'd just be 12.
Yep. And then you have the same base here, right? The x's are the same base, and so you can say, well, where do you have more, and how many more?
Oh, okay. So yeah, so we have on top. So we have more on top.
How many more?
Oh, how many? 20.
Good. And then we do 3 to the 4th, which it sounds like you might have a calculator by you too. So if you don't know what it is, you can do it in your calculator. You can either do 3 times 3 times 3 times 3, or if you can find the little button that looks like this, it's a caret symbol. It means to the 4th. That's going to be a symbol we're going to use later in the course as well.
I don't see that.
I
do have one of those computer or one of those calculators, but I have to get batteries for it.
Okay. Do you have it on are you doing it on your phone or?
No, I'm just doing it on like this little. So
calculator. It's normally up in the upper right-hand corner. but sometimes it's on the left side. It kind of depends on the calculator you're using.
I know. Oh, there's an exponent one, but it says x2.
Oh yeah, so near that, yeah, that's the square button. Let me see. Sometimes they don't use the caret. Sometimes they do x to the nth power like that on some calculators.
I thought I did the answer. Oh, is it 81?
Yeah. So, and then there'd be nothing in the denominator. It'd be like an invisible 1, which we don't need to write.
The answer would be 81x20. Okay. Okay. All right.
So I think, let's see. There's scientific notation, and that is, I believe, it. Yep.
Awesome. Thank you so much.
You're welcome. And please feel free to email any of those questions, do the message my instructor, so chapter 1 and 2, one of my colleagues kind of messed with my homework. And so there's a few questions in there. I think you found one of them yesterday, which I didn't necessarily normally have in there. So it didn't have the video. It was the absolute value of x was 16.
Yeah.
That was your question, right?
Yeah, but I totally, I think.
And you read it as
oh yeah, that one, the 16. Oh yeah, that one. So is the answer, yeah, those had me a little bit like frazzled. I was like, if I can't get through the first chapter.
So there wasn't a good example of the one on the left, and I didn't used to have that in the homework for this. It'll come up again later. But essentially, it had the definition, and the definition says absolute value of x will equal x. It'll be itself when x is greater than 0. So for positives, it's just what it is. So for example, if there's a 16 in here, it's just 16. But if I had -5 in here, when it's a negative, the absolute value of -5 is
5.
It's its opposite. So the way we show that is it's the opposite, negative x. It's the opposite of x when x is less than 0. And so that's what the rule was. So basically, here it's going to be 16. Absolute value of 16. Let me start that over. Eraser. Absolute value of 16 would equal 16 if that x were positive. Oops, I did not mean to put 16 in there. Absolute value of x equals 16. So either what's in here is 16 or -16. Both of those work. So in other words, when you're dealing with absolute value of an unknown, it's this distance to wherever is 16. So it could be 16 this way, or it could be 16 this way. And when you do 16 here, you get 16, and when you go this way, you get -16.
Okay.
And so this means what has an absolute value of 16.
Okay.
Versus
So
this is the absolute value of 16 is what?
Okay. Yeah, I'm super literal, so that's why I was struggling with that one, I think. Oh, no. Okay.
Well, I think you're struggling because most of the examples the examples in that section were this case. We're not asking you to solve. They were asking you to evaluate. And so I think you were just going like, oh, it's the positive.
Right. And I was wrong. Okay. Thank you so much.
But I think after chapter 2, at least my notes, if you keep coming to these sessions, will better correspond to the homework and to the material and to the textbook and everything. And most of this should. I think you just found like some of the rare situations, and then of course you found the one that had the coding error too, right?
Yeah.
So that's unusual. We find about one a semester. So hopefully this is it for the semester. And it's unfortunate it was in 1.1. I was like, oh, of all sections, why do? Because I don't want you guys to start off feeling like this program has mistakes in it, because it doesn't. typically. That was unusual.
Okay. Thank you so much for
You're
your
welcome.
time. I appreciate it.
Have a good night, and I'll have a similar thing where you can do like, video or like chat with me on Thursday, but it's not so much of a lesson. It'll be more a question and answer type situation.
Okay. And you're opening up the other, is it just going to be on the first lesson, not the second? Homework 1 through 4.
Let me see. What's part of Canvas thing? Let me double check where we're at here.
Yeah, we're just, I don't know if it's going to be like, I think, because you're opening up the second module for homework on Wednesday, you said, right? In the syllabus. So is on Thursday, will you be talking about that new homework or just this one?
I'll talk about anything you guys want to talk about on Thursday. It's I'm not going to do a mini lesson. Like, I'm not going to run through my notes.
Okay.
And let me double check the Canvas. Where is the Canvas? Oh. Are you seeing everything I'm pulling up here?
No.
Okay. Let's see. Canvas. Are you seeing my Canvas now?
Mm-mm.
Okay, that's fine. I didn't think so. I think I was just sharing the one screen where I had the homework or the notes. I can switch it over here if we need to. So yeah, this week's homework only went to 1.4, so we've taken care of all those sections. And then next Tuesday, I'll do 2.1 to 2.5, essentially.
Oh, okay. All right. So far, the questions, there's not so many. It's been manageable.
Yeah, and it will vary. I think you can actually see how many questions there are. You can't do them yet, but I think you can see. Like next week there'll be
it
16,
helps you like
13, 11, 14, and 12 questions.
Oh, yeah, that's awesome. Yeah, it helps you like okay, I have this many, and then I have to spread it out, of course, through soccer games and work and everything else.
Mm-hmm. So. All right. Well, I guess I'll see you next week, most likely, right?
Yeah, probably.
Okay.
All right.
In the meantime, feel free to message me. You don't have to wait till.
Okay. Thank you so much for your time.
You're welcome.
All right. Have a good night.
You too. Bye-bye.